All right, so the last thing we really need to understand before we move on into statistics, and I show you how to use Excel to derive your statistical analyses, is what types of data different numbers and different data fall into. So we have nominal, ordinal, interval, and derived data. And these are the four types of data that you really need to understand. So let's go through them together. So nominal data is basically any data that is categorical but doesn't have an order. All right? So in other words, this really is data that's qualitative. So examples of this are different colors of flowers in a field. So you can have 8 green flowers, you can have 8 red flowers, you can have 16 yellow flowers. These are, you're putting numbers, but you're basically categorizing them. They are either yellow, blue, green, red. It's a category. And you can't really put this in any order, all right? So maybe someone can say the order in which how much they like those flowers or whatever, but there's no real order to it. Other than some people's preferences, you can't say yellow is any better or rank them above or below red flowers and so forth. All right, same with supporters of different football teams. This is just categorical. So maybe we're putting people in the class, we have the Chargers, the people that like the Chargers still, and then we have the Chargers haters because they moved to LA. All right, so this would be categorical. You fall into one or the other. Or even if we started looking at what other football teams people like, you're going to fall into a category, and it's not a rankable category. And if it's not a rankable category, there's really no mean for this type of data. You can't find the average and so forth. All right, so anything that is basically categorical, you're putting it in this category or that category, that's nominal data, especially if it's not rankable. Ordinal now is still things that are in a category, but they can be ranked. All right, so oftentimes it really is qualitative data, but it is described by numbers. Right? So for example, oftentimes satisfaction level is in this regard. So if you are given a survey and you're told to give your satisfaction level on a scale of 0 through 10, that's a number, but it still is a category, right? You're putting your category of satisfaction into number 3 or number 5 or so forth, all right? Same with the number of tubes with Jell-O that solidify in the presence or absence of fresh pineapple, right? This is still categorical. The category here is that it did solidify or it didn't solidify. But now we can actually kind of rank these. So a satisfaction level of 8 is better than a satisfaction level of 5, right? And for example, you know, if 8 tubes solidified, that's more than 5 tubes solidifying in a different experiment. So this is still rankable, but these are still categories. And another good example is like rankings in sports. The difference between the number 1 and number 2 team might not be the same as the difference between the number 2 and number 3 team. All right, so all of these numbers are not an equal value apart. They're rankable, but they are really still categorical. They're not qualitative data. Right? And so we actually have a pretty good example of this. So you can calculate a mean, but that mean is highly suspect because what really is the difference between 5 and 10 versus 1 and 3? For example, in your satisfaction level, 0 to 10, most people really fall probably around 7 and 8. So the higher numbers there, the difference between a 9 and a 10 of satisfaction is not the same as between a 3 and a 4, for example. And we can see this with data that you're probably very well familiar with. These are your IDEA evaluations, all right? And so we're ranking satisfaction, kind of 1, 2, 3, 4, and 5. So I really wanted to take a course from this instructor. I really wanted to take this course regardless who taught it. As a result of taking this course, I have more positive feelings. Overall, I rate this instructor as excellent, and so forth. So here's some IDEA evaluation data. So here's my data, Dr. Crow's data. Here's your data for Caleb Smeraldi, the tutor, the TA for the class, that is. And so you can see here that, you know, these values are pretty low. So overall, I rate this instructor as excellent, 0.6. That means some of you had to give me a 0. That's not even an option, so I'm not sure, that's not very fair. But anyway, we can see these values here. They add up, average up to 2.24. And actually, I did pretty well in the fact that you wanted to take this course, regardless of who taught it. You just got stuck with me. So again, you can see that these numbers, even though this 2.24, it's not really a quantitative type of value. And if you go kind of this quantitative type of value, from this, it's obvious that Caleb is twice as good a teacher as Dr. Durrell. So these data obviously are made up in that regard, but you can see how the difference between a 4 and a 5 might not be the same as 3 and a 4. So these are numbers, but they're not really quantitative. So you have to be careful of data that looks quantitative because it's based on numbers, but really it's still just putting it in a category along the way. Then we get to data that is a lot easier to, or better to do statistics with. This is continuous data. Continuous data is rankable and has everything in between. So for example, heights. Heights is continuous data. And we can have anyone, even if two people are 6'0", chances are good they're not the exact same height. One of them might be 6.01 inches, or 6 feet, 0 inches, but there's 0.1 inch there. Some might be 6 foot 0.2, 6 foot 0.3 or something. There's always some differences there. This is continuous data. So lengths, all of these things are continuous. They can still have upper and lower limits, but the idea of interval data is that it's continuous and rankable. But in order to rank continuous data, because really, if you think about it, we know that mode means the value that had the highest number. The reality is with continuous data, there is no mode. There are no two people in this world that are the exact same height. If we could measure infinitely small values, we would find that everyone is a slightly different height. So in that regard, if you tried to rank everyone, yes, you can rank them smaller to taller, but there is no mode. So for that, we have to use bins. So we can see what's happened here. Bins is basically when you put them into a category based on a range within that. So these are people lined up that are 5 foot to 5'1". These are people that are 5'1" to 5'2", 5'2" to 5'3". So anyone that falls in that range gets put in that bin. And you can see with continuous data, with data that is interval, we start to get a bell-shaped curve. That is absolutely critical. So continuous data is actually quantitative data. It is rankable, it is continuous, and it's going to fit a normal distribution if you put it into bins like this. Please contact me and ask me if you have trouble understanding bins and so forth, but because we are going to use bins when we are starting to look to see if data is interval and if data is parametric later on. All right. Then finally we have derived variables. Derived variables are variables or data where we have done a calculation, all right? And so usually this is the result of making something into percentages, all right? So proportions, percentages, that's continuous data because you have a range, 0 to 100, but you can have any percentage within there. You can be 3.8%, you can be 35.2%, whatever it is, right? So let's look at this. Students receiving an A, B, C, D, or F in this course, right? That data right there would be ordinal, right? That data is ordinal. It's rankable. I know you all think A is better than B, but it is still categorical. It's not continuous. You're A, you're B, you're C, and so forth. But if we put that into percentage of students receiving an A, B, C, D, then you can start to have a continuous variable. There is anywhere from 0 to 100% of the students that are getting an A, and so forth. Hopefully 100%, right? This is how we worked with the tubes with solidified gel. We can take the number and turn it into percentage, right? So oftentimes, if you're taking data that is not interval data, you might have to do a derivation to get it to percent, and then you can start to work with it in statistics, all right? So the key here, though, that I really want you to understand is I want you to know what, I want you to know what nominal data is. That is data that's categorical and non-rankable. Ordinal is data that is categorical but rankable. Interval is data that is quantitative, it's continuous, and you can use bins to kind of see that, and it's rankable. And then derived data is data that you've done a calculation, usually to make percentage, to really get that data. So, At this point, I want you to go on Canvas and just kind of take the quiz on what type of data is this, think it through, and then get the feedback. Make sure you're really looking at the feedback because that's where the correct answer is explained for you. And then hopefully we're ready to go with this.